Welcome, my dear students. I am Dr. Subha Gaurab, Assistant Professor, Department of Physics, SS College, Hailakandi. I am about to take my third class of HS first year, and it's on error analysis. Now, on the previous two classes on error analysis, we have extensively derived the expressions of fractional error, relative error, and percentage error, and have seen few other things like absolute error, maximum permissible error, etc. So today's class we shall be focusing mainly on the numerical problems that we have to solve in order to complete our discussion on error analysis. But before I begin today's discussion, I would like to just recapitulate few things that we have done. The first thing which we have already done is we have written that if x represents the true value of any physical quantity, it can be expressed as x equal to x average plus minus delta x, where x average stands for the measured value, delta x represents the error. This is what we have understood and we are discussing from our very first class. Then we have discussed that if the expression of x is such that it comprises of a plus b, where a and b are the quantities which we can measure, then the expression for fractional error or relative error is given by delta x by x, and that is equal to plus minus delta a plus minus delta b. If I have to now find out the expression of percentage error, then what I have to do? I have to just multiply this delta x by x by 100. Delta x by x into 100%. That will give me the percentage error. Similarly, we have done if the form of x is AB, then the expression for relative error is delta x by x equal to delta a by a plus delta b by b, and there is a plus minus sign. So if I have to do the percentage error, just I have to multiply this one by 100 and put a percentage sign there. Thereafter, we have obtained the similar expression for the form of x to be x equal to a to the power m. In that case, we have written delta x by x equal to m delta a by a, where this m is nothing but the integer which is appearing as a power of a on the expression of x equal to a to the power m. Percentage error, if I want to get here, then just I have to multiply here by 100 and put a percentage sign. Thereafter, we have also obtained the expressions of percentage error and relative error if the form of x is x equal to a by b, for which the expression for relative error was delta x by x equal to plus minus delta a by a plus delta b by b. And finally, we have written if the form of x is such that x equal to a to the power m, b to the power n by c to the power l, then the expression of relative error or fractional error comes out to be delta x by x, that is equal to plus minus m delta a by a plus n delta b by b plus l delta c by c. So this is what we have discussed in our previous class. So if the form of x is this one and I want the percentage error, then just I have to multiply this entire thing by 100 and put a I have to multiply by 100 and put a percentage sign. Then this will give me the expression of percentage error. So up to this much we have discussed in our previous two classes. Now let us focus on to our today's discussion. Today we want to discuss exclusively the numerical problems that often comes in various competitive exams and also in your council exams based on error analysis. That means based on the discussions so far we have done. So the very first problem that I used to discuss with all of you is this one. A problem is there. The problem is such that an experiment measured quantities a, b, c, and then x is calculated from x equal to ab square by c cube. If the percentage error in ABC are 1%, 3% and 2% respectively, what will be the percentage error in the measurement of x? So this is specifically the question that we have. Now, before I go for solving this, I would like to say that whenever in physics particularly we will be encountering any numerical problem, the first task is to identify the things that are already given in the question. So first we have to identify, we have to detect the things or the parameters that are already supplied in the question. And there are also, along with that, we have to understand, we have to categorize the particular thing which we have to identify. So for that, you focus on this particular question. You see which things are given. The expression of x is given, percentage error in A, B, C. Now we know if we have a quantity A, then the percentage error in A will be delta A by A into 100. So I have written given, that means these are already supplied to us. Given delta A by A into 100 is equal to 1%. Percentage error in B is 3%, that means delta B by B into 100 is 3%. Percentage error in C is 2%, that means delta C by C into 100 is equal to 2%. So these are the things already given to us. Now what they want from us? They want the percentage error in x. So what will be the expression of percentage error in x? It will be delta x by x into 100. So this is what we are to calculate. Now before I straight away write, so I want to say that what is the expression of delta x by x if the form of x is this one? If the form of x is this one, then what is the expression of delta x by x? So give here x is equal to a b square by c cube. Now before I write the expression of, so delta x by x will be equal to, before I write the expression, I would like to just show you the formula which we have just written. If we have a to the power m, b to the power n by c to the power l, then delta x by x becomes plus minus m delta a by a plus n delta b by b plus l delta c by c. In our given question, if we compare these two, which two? Our given expression x equal to a b square by c cube, x equal to a b square by c cube, with, if we compare this expression with the form x equal to a to the power m, b to the power n by c to the power l, then clearly we see that the power of a is 1 here in our given question. That means m has to be 1. b to the power n is appearing here as b square, so n will be 2, and c to the power l appears as c cube, so l will be 3. So just I'll just put the values of m and l here, and just I'll write it. So I think I can write delta x by x equal to, power of a is 1, so it is 1 into delta a by a, plus power of b, that is 2 into delta b by b, plus power of c, that is 3 delta c by c. Therefore, as this is the expression of relative error, therefore the percentage error in delta x, which we have to find, that is delta x by x into 100, that will be equal to delta a by a into 100 plus delta b by b into 100 plus 3 delta c by c into 100. What I have done is that I have just multiplied this entire equation by 100 so that we can get the expression of percentage error. Now as per our given condition, as per our given condition, delta A by A into 100 is 1. So I will put delta A by A into 100 is equal to 1, because you see it is already given 1. So I put the value of delta A by A equal to 1% plus 2 into delta B by B into 100. So delta B by B into 100 is given here as 3. So it is 2, this 2 multiplied by 3% plus this 3 multiplied by delta C by C into 100, which is again 2%. So what I get? 3 to the 6, 3 to the 6 plus 1. So 6, 6, 12 plus 1, that is 13. So this is 13%. So the very correct answer of this question is that the percentage error in the measurement of x is 13% when x equal to ab square by c cube, and the percentage error in ABC are 1%, 3% and 2% respectively. So this is all about our first numerical problem. Now let us focus on to this particular problem, which is very important also. The problem says the error in the measurement of radius of a sphere is 0.5%. It says the error in the measurement of radius. Error in the measurement of radius of a sphere is 0.5%. What is the permissible percentage error in the measurement of surface area and volume? So let us first write the things that are given to us. Percentage error or measurement of radius of a sphere is this one. Error in the measurement of radius of a sphere is this one. Error in the measurement of radius is 0.5%. That means it is percentage error. That means as per the given condition or given question, delta R by R into 100 is given to be 5%, where R is the radius. Where R is the radius. This is what is given. Now what they want the percentage error in the measurement of surface area and volume. Say surface area, say the expression of surface area or the symbol of surface area, let us denote it by capital A. That means it is the area of the surface of the sphere. And we know the expression of surface area is 4 pi r square. Because we have to find percentage error in the measurement of surface area, and also we have to find the expression of percentage error in the volume. Now what is the volume of a sphere expression? It is 4 by 3 pi r cube, where r is the radius. Now if the expression of A is this one, then what will be the expression of delta A by A? We have to write. So delta A by A will be equal to, what is the power of R? It is 2. So it will be 2 into delta R by R, because you are dividing delta A by A. So when you are finding delta A, then 4 pi will be constant. When you are dividing it by A, again there will be 4 pi. So 4 pi will get cancelled out. So 2 into delta R by R. So percentage error in surface area, it will be delta A by A into 100. That is what they want. So this will be equal to 2 delta R by R into 100. That means I have multiplied both the sides by 100. Now as per the given condition, delta R by R into 100 is 5%. So it is 2 multiplied by 5%. So not 5, it is 0.5. On the question it is 0.5, 0.5. So I just forgot to put the 0.5. So 2 into 0.5, that means 1%. So this is the percentage error in the measurement of surface area when the radius of a sphere is having percentage error 0.5%. Now see the case of percentage error in the measurement of volume. Now if this is the expression of volume, then clearly I think right now we are in a stage to write the expression of relative error or fractional error instantly. So delta V by V will be equal to 4 by 3 pi seems to be constant. So it will not appear in the expression of fractional error. So delta V by V will be equal to, what is the power of R? It is 3. Then delta R by R. Now what we need to find out? We need to find out delta V by V into 100. So this will be equal to 3 into delta R by R into 100. Again, as per given condition, given question, delta R by R into 100 is 0.5%. So it is simply 3 multiplied by 0.5%. So this is 1.5%. So this is the answer of percentage error in the measurement of volume of a sphere having percentage error in the radius to be equal to 0.5%. Now let us focus on to our third numerical problem. The problem says the length of a cylinder is measured with a stick having least count 0.1 centimeter. Its diameter is measured with vernier caliper having least count 0.01 centimeter. Given that the length is 5 centimeter and radius is 2 centimeter, find the percentage error in the measurement of volume. The question seems to be a bit long, but it is not very difficult. It is also very easy. Just as I said, first we have to just mark the things that are already given to us and let us decide the particular quantity that we have to find out. So solution will be first of all, what do we have to find? Find the percentage error in the measurement of volume. That means volume, percentage error in volume we have to find. Now length of a cylinder. So the problem is all about related to cylinder. Now I would like to say that the expression for volume of a cylinder is V equal to pi d square by 4 into L, where L is the length, D is the diameter. D is the diameter, L is the length. Now if this is the expression of volume, then what will be the expression of fractional error? This will be delta V by V. This will be equal to pi by 4 will appear to be just like constant. So they will not appear. D and L are the quantities which we need to measure in order to find the volume of the cylinder. Therefore, we will have errors in the measurement of diameter, that is capital D, and also in the measurement of length. So delta V by V will be equal to 2 into delta D by D plus, what is the power of L? It is 1. So it is simply delta L by L. This is the expression of fractional error. But we need to find out the expression of percentage error. That means delta V by V into 100. That means this is what we have to find out. Now let us focus the things that are given to us. Now before I go further, before I take my discussion further, I would like to just tell you to keep one thing in your mind. If you find the term least count when you are dealing with problems related to error analysis, the moment you find a term least count, L-E-A-S-T-C-O-U-N-T, be sure that it is nothing but error or permissible error. Error or permissible error. Or permissible error. This is just what you keep it in your mind. I am not going to discuss in details least count because we will be doing it in our practical classes. But just for solving this problem, just let me remind you that least count is all about error. If any measuring instrument has got some least count, for this particular purpose, you can consider that you may have this much amount of error. Now it is said in the question that length of a cylinder is measured with a stick having least count. That means when you intend to measure the length of the cylinder, your least count is 0.5 centimeter. That means delta L is nothing but 0.1 centimeter. So I am writing here, as per given condition delta L is 0.1, but this is not percent. You see here it is only written list count. It is not percentage error, or this figure is not represented with a percentage sign. So this means it is just simply an error. So delta L is equal to 0.1. Similarly, you see its diameter is measured with vernier caliper. Vernier caliper is a device with the help of which the diameter of small cylinders can be measured. We shall be dealing with vernier calipers during our practical classes, but keep it aside. So when the diameter of the cylinder was measured with a device called vernier caliper, the least count was 0.01 centimeter. When length was measured, least count was this much, 0.1 centimeter. And when diameter was measured, the least count was 0.01 centimeter. That means delta D will be equal to 0.01 centimeter, and this one was also centimeter. So we have got delta L, delta D, and with this setup it is also said that length is 5 centimeter and radius is this much. So length is 5 centimeter. That means L is equal to 5 centimeter and radius is 2 centimeter. So if I say radius is 2 centimeter, then definitely diameter will be just double of that. That means 4 centimeter. So I think now we have all the things that are being supplied to us. So let us just put these values one by one here and find the ultimate value. So 2 into delta D by D. Delta D is 0.01 divided by D is 4 plus delta L by L. So it is 0.1 divided by 5. So an entire thing multiplied by 100. So here the result comes out to be 0.5 plus 2. After you multiply it by 100, so the answer comes out to be 2.5%. 2.5%. So this is the answer. This is the answer of the question. Now let us see the problem. Next problem. A wire has a mass 0.3 plus minus 0.003 gram, radius 0.5 plus minus 0.005 meter, and length 6 plus minus 0.06 centimeter. Calculate the maximum percentage error in the measurement of density. So solution, let us see. So first, the things that are given to us. Which things are given? Mass is expressed in this form. Now if you remember, the standard way of representing the true value is measured value plus minus error. That means what? If I represent mass by m, then m is nothing but 0.3 gram and delta m is nothing but 0.003 gram, because true value is measured value plus minus error. This is how the result is being expressed here. Now see the radius. So if r is the radius, say, then r is nothing but 0.5 meter. Sorry, it is millimeter. In the question it is written to be millimeter. Although it's not a matter whether it's in millimeter or centimeter. And delta r will be 0.005 millimeter. Length, delta L will be 0.06 centimeter and length will be 6 centimeter. So these are the things that are already given to us. we have to calculate the maximum percentage error in the measurement of density. So how do we represent density? Density is represented by a symbol called rho. Symbol called rho. This is the symbol of density. Density is what? It is mass by volume. Mass per unit volume. So the expression of density is rho is equal to mass of the wire divided by the volume. Now what is the expression of volume of a wire which has got radius and length? This is simply pi r square L. So the expression of rho will be m by pi r square L. So this is the expression of density we have, and we have to find the maximum percentage error in its measurement. So if this is the expression of rho, then what will be the expression of delta rho by rho? Delta rho by rho will be, there is m, so there will be power of m is 1, so delta m by m, plus power of r is 2, it is 2 delta r by r, plus power of L is 1, so it is simply 1 into delta L by L. Now as per the given condition, delta M, value of delta M, delta R, delta L, these are all given. So we have to just plug in the values in this equation. So delta M by M, that means 0.003 by 0.3, both are in gram, so there will be just a numerical number, plus 2 into delta R by R, 0.005 divided by 0.5, plus delta L by L, 0.06 by 6. So this is the value of fractional error, delta rho by rho. So the percentage error which we have to actually obtain, this is this one. So this will be equal to 0.003 by 0.3 plus 2 into 0.005 by 0.5 plus 0.06 by 6 into 100%. So now you see, if I multiply 0.003 by 100, there will be 0.3. So that 0.3 and this 0.3 will just cancel out, and I will have a 1 here. 0.005 multiplied by 100, it will be 0.5. So this 0.5 appearing in the numerator will cancel with the 0.5 appearing on the denominator. So there will be again 1. So 1 into 2 will be 2. Plus there will be 0.06 multiplied by 100, it will be 6. So 6 by 6 is again 1. So this much percent, that means it is 4%. This is the answer. I hope you are able to understand the problem. Now let us focus on to our next problem. The problem is that the length of one rod is 3.25 centimeter and that of other rod is 3.31 centimeter. That means there are two rods. There is no confusion. The least count of the measuring instrument is 0.01 centimeter. It means there are, say, two rods. Say there are two rods. Say one rod is 3.25 centimeter and another rod is, say, 3.31 centimeter. And least count of the measuring instrument, that means the device or the instrument with which the length was being measured, that instrument's least count was 0.01 centimeter. That means even when the length of this rod was measured, in that time also the instrument was having least count 0.01 centimeter. When the length of this rod was measured, then also the instrument had an error, had a least count of 0.01 centimeter. That means when length of this one was measured, say I call delta L1, say the error in the measurement of length of this rod, say delta L1, it will be 0.01 centimeter. Say I represent the error in the measurement of length of this rod by delta L2, then this will also be 0.01 centimeter. Because in the question itself it is said least count of the measuring instrument is 0.01 centimeter. So thereafter it says if the two rods are put end to end, that means just a join, this is say end, this is say end, or end to end means this is also one end. So just if I join both the rods, that means this one, and thereafter just I join both the rods. If I join both the rods, then how to express the combined length? Now this 3.25 is measured value, this 3.31 is again measured value, but error in the measurement of this particular rod's length is this one, error in the measurement of length of this particular rod is this one. So the question is asked about how we can express the combined length. So definitely here what we find is that error in when I'll definitely join, but the errors in measurement of length of this one is this one, error in the measurement of length of this particular rod is this one. So total error will be delta L1 plus delta L2. So this will be equal to 0.01 plus 0.01, that means 0.02 centimeter. This is the error. So definitely amount of error we have got. Now measured values are what? 3.25 and 3.31. So the length of the combined rod, this will be equal to this 3.25 plus 3.31 plus minus the total error 0.02 centimeter. That means 6.56 plus minus 0.02 centimeter. This is the answer. So nice problem. Now let us focus on to the next problem. This is a different type of numerical problems. The value of two resistors are 5 plus minus 0.2 kilo ohm and 10 plus minus 0.1 kilo ohm. Calculate the percentage error in equivalent resistance when they are connected in parallel. I hope you have got the term resistor, that means resistance, in your class 10. And how do we represent resistance? This one, like this symbols. Say there are two resistances R1 and R2, and you have to find the percentage error in equivalent resistance when they are connected in parallel. Now we know when the resistance are connected in parallel, then the expression of equivalent resistance is 1 by R is equal to 1 by R1 plus 1 by R2, where R is the equivalent resistance. Now if this is the expression, then R becomes R1 R2 by R1 plus R2. So this is the expression of equivalent resistance when the resistance are connected in parallel. Now if this is the expression of equivalent resistance and we want percentage of error or percentage error in the measurement of this capital R. Now if this is my supplied expression, then what will be the expression of delta R by R? Let us first find out. As this is the expression of R, so delta R by R will be, now forget about the denominator. If it is of the form AB, then it is delta A by A plus delta B by B. So it is also having form R1 R2. First focus on the numerator. So it will be delta R1 by R1. You think that R is equal to, you just think R is equal to AB by A plus B. So what will be the result? If it is AB, then delta A by A plus delta B by B. So delta R1 by R1 plus delta R2 by R2. Now we concentrate if the form is A plus B. Now just for example, you consider that the form is AB divided by some quantity C. Then what will be the expression? If delta A by A plus delta B by B plus delta C by C. Now here this C becomes R1 plus R2. So it will be plus again delta R1 plus R2 divided by R1 plus R2. So this is equal to, again I can write delta R1 by R1 plus delta R2 by R2 plus delta R1 divided by R1 plus R2 plus delta R2 divided by R1 plus R2. Fine. So now let us put the values of delta R1 and R1, delta R2 and R2. Now say for example we are considering this resistance, the resistance which is having expressed as 5 plus minus 0.02 kilo ohm. Say this is our R1, this is our R2. You can even consider this is R1, this is R2. There is no problem. It is arbitrary. Choice of R1, R2 is arbitrary. So let us consider that this is R1, this is R2. That means R1 is 5, R2 is 10, delta R1 is 0.2, delta R2 is 0.1. Just it is up to us to consider R1 and R2 and all that. So just straight away I am putting the value. Delta R1, it was given 5 plus minus 0.2. Let it be R1. So this is 0.2 divided by 5 plus another resistance was given 10 plus minus 0.1. We are representing that one by R2. So this will be 0.1 divided by 10. So this part is over, plus delta R1, that means 0.2 divided by R1 plus R2, that means 5 plus 10 is 15, plus delta R2, it is 0.1 divided by again 5 plus 10, 15. Now the question asks about percentage error in the equivalent resistance. So it will be, this is delta R by R. So delta R by R into 100, this will be equal to, for these two terms, it will be 0.2 by 5 plus 0.1 by 10 into 100 plus, just I am separately I am writing 0.2 by 15 plus 0.1 by 15 into 100, and just after all you put a percentage sign. So this is equal to so it will be 0.4 plus 0.1 multiplied by 100 plus 0.3. I have taken here LCM of 5 and 10, here LCM of 15 and 15. This multiplied by 100. So here 0.5 multiplied by 100 divided by 10, it will give me 5. And 0.3 multiplied by 100, it will be 30. Divided by 15, it will be 2. 5 plus 2 percent. That means the answer is 7%. So here is the problem. It is also a problem of different kind. Now our next problem. The problem says percentage error in the measurement of mass and speed are 1% and 2% respectively. What is the percentage error in kinetic energy? Solution. First of all, which things are given? Percentage error in the measurement of mass and speed. Let us represent mass by m. So delta m by m into 100 is equal to 1%. It is given. Percentage error in speed. Let us denote speed by v. That means delta v by v into 100. This is equal to 2%. These are the things given to us. What they want? Percentage error in kinetic energy. Let us denote kinetic energy by K. Kinetic energy. Let us denote kinetic energy by K. So K is equal to, we know kinetic energy expression, half mv square. Half mv square. Now if this is the expression of kinetic energy, then what will be the expression of delta K by K? Delta K by K will be delta m by m plus power of V is 2, so 2 delta V by V. So percentage error in the measurement of kinetic energy, that means delta K by K into 100. So this will be equal to delta m by m into 100 plus 2 into delta V by V into 100. Now as per given condition, delta m by m into 100 is given to be 1%. So this is 1 plus 2 into delta V by V into 100 is 2. That means 2 multiplied by 2. So this equals 5%. So I think we have done enough of elaborative numericals on error analysis. Now just focus on 2-3 MCQs. The first one is this one. The question is, the mean time period of a simple pendulum is 1.92 second. Mean absolute error in the time period is this one. To express the maximum estimate of error, the time period should be written as which particular option? Now the question says time period of a simple pendulum. We know simple pendulum, its time period means time taken by it to complete one oscillation, is given as this one. That means they have measured. That means this 1.92 is nothing but the measured value. Now mean absolute error. I think you remember we have talked about average of the absolute errors. That means the mean of the absolute errors in our very first class. Delta x1, delta x2, delta x3. All those were individual absolute errors. And the average of all the individual absolute errors gave us the mean, delta x. So here, this mean absolute error means the error. Therefore, how to represent? The mean time period of a simple pendulum is this one, 1.92 second. Mean absolute error in the time period is this one. To express the maximum estimate error, time period should be written as. So clearly you see, we know that true value is expressed as measured value plus minus delta x. That means plus minus error. So definitely it is nothing but 1.92 plus minus 0.05. So this is the answer. Now let us see the next MCQ. Which of the following expresses the most accurate measurement of length of a rod? 500.0 millimeter, 500 millimeter, 50 centimeter, 0.5 meter. You see 500 millimeter, 500 millimeter, 50 centimeter, 0.5 meter, all these are same. 0.5 meter is nothing but 50 centimeter. 50 centimeter I can write it 500 millimeter. I can also write 500.0 millimeter. But which result, which option shows the most accurate one? Now you see the units are millimeter, centimeter, meter. So the lowest one is millimeter. So definitely option will be either A or B. Now amongst A and B, on A we are having some figure after even the decimal point. So clearly it indicates that this is more accurate. The way, the format or the form in which the result is being expressed, this one seems to be more accurate because it has displayed some digit even after the decimal. So definitely the correct answer is A. Now let us see the last MCQ. The question is, the initial temperature of water is 20.5 plus minus 0.1 degree centigrade. A cube of ice is added to it. When the cube is completely dissolved, the final temperature of the mixture is 18.4 plus minus 0.1 degree centigrade. The fall in temperature of the water will be. What the question says is that there is some water, fine? There is some water, and whose initial temperature is how much? 20.5 plus minus 0.1 degree centigrade. And a cube of ice, say a cube of ice is being added to it. So definitely if ice gets added to normal water, then the temperature is likely to fall. So ice took, of course, some time to get resolved, and finally the temperature of this mixture became 18.4 plus minus 0.1 degree centigrade. So there is clearly a reduction in the temperature. Now the question is about fall in temperature of the water will be. Means how to represent the fall in temperature. So here measured value is 20.5 initially, and finally the measured value is 18.4. So how much is the reduction? 20.5 minus 18.4, so it is 2.1. So measured value will be 2.1, and initially the error was 0.1, finally again the error was 0.1, so total amount of error is 0.1 plus 0.1, that means 0.2. Initially, when the temperature of the water was being measured, amount of error was 0.1. Finally, when again the temperature of the mixture was measured, again there is an error of 0.1. So total amount of error it's an additive quantity, it just get added. So 0.1 plus 0.1, it becomes 0.2. So 2.1 plus minus 0.2. So the correct option is option number A. So I wind up my today's class here, and I am sure with the things that we have covered in today's discussion, you will be able to do rest of all the problems whichever comes to your way on your various exams. Thank you.